Hello students, welcome back to all. In this video, I'm going to explain about the formation of C2H2 molecule, right? So generally, C2H2 molecule, its common name is called ethyne, right? And it is also having another name, that is acetylene. So now, let us see how the C2H2 molecule will form and which type of hybridization will take place in C2H2 molecule. So let me explain all the topics very clearly. So we know that in C2H2 molecule there are two carbon atoms and two hydrogen atoms bonded with each carbon atom. So this is C2H2. In between the two carbon atoms there exists a triple bond, and each carbon atom is bonded with the hydrogen atom in each case. So this is the formation of C2H2 molecule generally. Now let us see how the triple bond will form and which type of hybridization will take place. Let me explain. So we know that generally the carbon, its atomic number is 6 and its configuration is 1s2, 2s2, 2p2, right? So in the outermost shell it is containing 4 electrons. So we know all those things. So this is called ground state electronic configuration, right? And here what is the excited state electronic configuration of carbon atom? So that is 1s2, 2s1, 2p3, which means what happening here, one electron from s orbital is excited to 2p orbital. So here 2s1 means in s orbital it contains one electron. 2p3 means there exists 2px1, 2py1, 2pz1. So this is 2px1, this is 2py1, and this is 2pz1. So this is 2s1. So this is the first excited state electronic configuration of carbon atom in the outermost shell. So now here in case of ethyne, in both the carbon atoms the sp hybridization will take place. Which means here one s orbital and one p orbital undergo hybridization. See here only one s orbital, one p orbital intermix each other. S plus p undergo hybridization and gives sp hybridization. Here two new sp hybrid orbitals will form in each carbon atom, right? And the remaining two p orbitals here there 2py and 2pz. These 2py and 2pz orbitals remain here unhybridized. So it is very important point. Here the 2py orbital and 2pz orbital in both carbon atoms remains unhybridized, which means they are not participate in the hybridization. Only here one s orbital, that is 2s orbital, and 2px orbital. These two orbitals will participate in the hybridization and gives two new sp hybrid orbitals in both the carbon atoms. So let me draw the diagram. So now each carbon atom is having two sp hybrid orbitals. So this is one hybrid orbital, this is another one. So there is another carbon atom, it is also having two hybrid orbitals. So first one, second one. So here what happening here? Here one hybrid orbital of the carbon atom is overlapping axially with the other hybrid orbital of the other carbon atom. So here the two carbon atoms are there. When the two carbon atoms approach each other, here there exists a sigma bond because the axial overlapping takes place in between the two hybrid orbitals of two carbon atoms. So here what happening is, so this is carbon atom. So these are the two orbits. And draw the second carbon atom. So these are the two hybrid orbitals. So this is the first carbon atom's hybrid orbital. This is the second carbon atom's hybrid orbital. So here these two hybrid orbitals in between there exists a sigma bond because the lateral axial overlapping takes place here in between the sp orbitals of the two carbon atoms. So in carbon-carbon there exists a sigma bond. And here the remaining two hybrid orbitals will overlap with the 1s orbital of the hydrogen atom, because we know that in hydrogen atom there exists only one electron, that is 1s1. So here the remaining two hybrid orbitals is overlapping axially with the half-filled 1s1 half-filled orbital of the hydrogen atom. So here also sigma bond will form. So like this, the two hybrid orbitals is overlapping laterally with the two hydrogen atoms. So here also sigma bond will form. And now here only in between the carbon atom only single bond is exist. Then what about the double bond and triple bond? So we have to remember one more point here. So here in both the carbon atoms we discussed the py orbital and pz orbitals in both the carbon atoms remains unhybridized. So in both carbon atoms there are two orbits are there. So this is py orbit, and let me draw one more. So this is pz orbit. So here also this is py orbit and this is pz orbit. So this is 2py, this is 2pz. So here the lateral overlapping, sidewise overlapping takes place in between the 2py orbitals. So here 5 bond will form. Is it clear? In the same way, in between the, let me draw. Okay, in between the 2pz also there exists a lateral overlapping. So here also pi bond will form. So like this, in between the two carbon atoms there exists a triple bond, one sigma bond and two pi bonds. Okay, this one sigma bond is in between the sp hybrid orbitals of the two carbon atoms, and two pi bonds in between the 2py orbitals and 2pz orbitals, in between 2py and in between 2pz. So like this, in C2H2 molecule, in ethyne molecule there exists a triple bond, and the carbon atom is bonding having single covalent bond with the two hydrogen atom. So this is the formation of C2H2 molecule. So like this, the sp hybridization will take place in case of C2H2 molecule. So this is today's class. Thank you.